Hello. Last time we have discussed about the interrupts. Now today we are going to discuss about the ports. So basically we will start with the input output ports programming. So as we know, the 8051 has four 8-bit ports, that is P0, P1, P2 and P3. Each port has D-type output latch for each pin. Now all the ports upon reset are configured as input, ready to be used as inputs. When the first 0 is returned to a port, it becomes an output. To reconfigure the port as an input, a 1 must be sent to the port. So we whenever microcontroller writes 0 to the port, it means that port should be working as an output. To reconfigure that particular port as an input, a 1 must be sent to that particular port. So this is all about the input output ports, how port is uh, how port is working as a input or output. So first it has four ports. First one is port 0. So port 0 is basically uh, it is used for input or output, and also designed as AD0 to AD7, which means these are the multiplexed bus. That means it is used for the both purposes, that is address and data. So for this port, when control is 1, this port is used as address or data interfacing. When the control is 0, the port can be used as a normal bidirectional input output port. So port 0 is used as address and data multiplex line when external memory is connected. So this is port 0. Next is port 1, in which port 1 does not any dual function, that is it is dedicated for input output interfacing. Therefore output latch is connected directly to the gate. So basically port 1 is dedicated input output port because it is basically used for input output interfacing. When it is used as output port, the pin is pulled up or down through internal pull up. Upon reset, port 1 is configured as an input port. For example, uh, if we have instruction like move a comma hash 55h, move p1 comma a, it means that the contents of accumulator must be moved to the port number 1. So this is the port 1, which is dedicated port used as a input output interfacing. Next one is port 2. Port 2 has the input output operation similar to port 1. It is used for higher external address byte or normal input output port to address the external memory. Port 2 has high order address byte in conjunction with port 0 low order byte. So last we have port 3. So in port 3, it basically contains the different number of pins. It has alternate use and the special function register. So first one is RxD, that is serial data input. Next one is TXT, that is serial data output. Next one is INT 0 bar, that is external interrupt 0. Next one is INT 1, that is external interrupt 1. Next one is T0, external timer 0 input. Next one is T1, external timer 1 input. Next it has WR bar, that is external memory write pulse. Next it has RD bar, that is external memory read pulse. So this is the port 3, which contains different number of pins, and each pin has its own alternate use or its own function. Till now we have discussed the different ports used by 8051 microcontrollers, their pin number and their alternate functions. So now we will discuss the example of each and every port. For example, we need to write a code to continuously send out to port 0 the alternate values 55 and double AAH with the help of P0. So first of all we will start with, as we know, we need to transfer, or we need to use two possible values, that is 55H and double AH, which need to be continuously sent out to the port 0 alternatively. So first of all, 55H is an immediate data, so that should be moved to accumulator with the help of move a comma hash 55H instruction. Next, that value should be moved to P0 port, so next instruction will be move P0 comma A. Now we need to add certain delay in this program, so we will just call a delay with the help of instruction a call delay. Now we are, until now we have done with the 55H. Now we are interested to transfer double AH into the accumulator, or that double AH should be sent to the port P0. So here we have instruction move again, double AH is an immediate data, so we have instruction like move a comma hash double AH. Now that instruction, that value which is present at accumulator must be moved to P0, so we have instruction like move P0 comma A. Now again we will insert certain delay with the help of instruction a call delay. Now this process is continuous, it means the 55H and double AH data should be inserted continuously in port through port 0. So we need to add a loop. So first instruction is move a comma hash 55. Suppose we have mentioned again label to that particular instruction, so we are just keep calling that particular label with the help of instruction s jump again. Now second example is to send out to port 1 the alternating values 55 and double AAH. So in this port 1, we, as we know, hash 55H is an immediate data, so we have instruction move a comma hash 55H. That data should be moved to P1 with the help of instruction move P1 comma A. We will gonna we will go we will insert a certain delay in this program, so we need to call an instruction a call delay. Now now accumulator is containing data 55H. If we find out the first complement of 55H, so it will give value double AH. Now in a previous program we have send hash 55H individually to the accumulator. Later on we transferred hash double AH into the accumulator, but in this program we can just complement that contents of accumulator. That is, we if suppose we find out the complement of 55H, then we will get result like double AH. So after CPL A, which means it inverts the contents of register A, so we will get the answer double AH. That should be moved to again P1 port. Now we are interested to insert 55H and double AH value at alternate position continuously, so we need to follow the loop continuously. We will continue that flow of the loop with the help of instruction s jump again. Again is nothing but the label which is given to the first instruction of the program. Now this is the example in which port 2 is configured first as an input port by writing 1. So and then data is received from the port and it is sent to P1 continuously. So in this we get byte from P2, and say we need to accept the byte from P2 and that byte should be sent to the P1. So first instruction, suppose we use double fh data which is to be accepted from P2 and later on it will be sent to the P1. So first instruction is move a comma hash 55h. Again 50 double fh is an immediate data, so hash sign should be used for an immediate data. Next, that data should be moved to the that data should be moved to the port 2. So we have instruction like move P2 comma a. Next, that data should be again moved to the accumulator. So next instruction is move a comma P2. Now we are having double fh data in P2 also as well as in accumulator also. So now we are interested to send that double fh data to the P1. So we need to use the instruction move P1 comma a. So by using this instruction, that double fh data should be sent to the P1, and after that this process should be in continuous mode. So that's why we need to write a loop for that particular instruction. So we just need to call that particular loop with the help of instruction s jump back. By using this instruction, we keep accepting the data from P2 port, and we are keep sending data to the P1 port.